All right, welcome everybody to today's lecture. We're going to be talking about a couple very interesting topics that are interrelated um, today. We're going to be talking about swarms and laying workers. Now, each of these topics are very different from one another from a distance, but as we will learn today, they are linked and are each excellent examples of how important it is for you as a beekeeper to clearly understand what you're seeing in a hive and how to address the needs of a hive so you prevent colony losses due to both of these situations, both laying workers and swarms. So let's get into it today. So the first topic we're going to jump into in today's lecture is swarming. So I'm sure most of you are familiar with the concept of swarming in the sense that a bunch of bees will periodically be found on a tree or in the corner of your house or maybe in the wall of your neighbor's house or even on your neighbor in this situation. But what we're observing in these situations is the old queen from a colony has left with a good chunk, almost a majority of the workers and drones to establish a new colony. And what they leave behind is a virgin with workers and brood and food in the old hive that they've swarmed from, and they turn essentially what's happening is one hive is turning into two in this situation. As beekeeper, we really never want our bees to swarm because we're essentially losing half of our bees. So understanding how and why bee swarms, it's going to help you prevent that loss and really capitalize on this impulse to reproduce. All right, so there are two reasons bees swarm. It's either because the colony is going through the natural process of reproduction, which is at the colony level, or the hive is overcrowded. And we're going to start by looking first at the swarming from a reproductive angle. All right, so swarming is really all about reproduction. So what we're really talking about when we're talking about swarming at its core is a behavior for reproduction. Now, we're not talking about reproduction in the sense that a queen is mating with drones and laying eggs within a colony that's producing new bees. That is an individual form of reproduction within a single colony. What we're talking about is reproduction at the colony level. So how does the entire colony reproduce naturally to replace colonies that are lost during the winter or to disease or maybe another factor affecting the survivability of a bee colony? And this is purely a natural process. There is nothing unnatural about this. Humans didn't always keep bees, and swarming is the behavior that is hardwired into the species to ensure survival in the wild. Keep in mind that swarming is also a very risky behavior. In typically a weak or sick colony that's struggling does not swarm. That's not typically something that happens. They don't have the resources or the population to really embark on a risky endeavor when it's a small colony. Really, what you're looking at is that these are your strongest colonies, your healthiest colonies that are doing this. And really, what you want to make sure is that you are able to capitalize on this and not lose these bees. Really, what you need to be thinking is that, really, before we were here, keeping bees, they were reproducing in the wild like this. It's a natural process, like I said before. And again, it's going to be your most robust colonies that swarm. It's not going to be your weak, dinky colonies. And so we want to make sure that we recognize what is causing swarming and how we can prevent it or stave it off through different management techniques. All right, so reproductive swarms they tend to be very seasonal, and they're stimulated by shifts in temperature and day length and resource availability. So they're typically going to occur for a couple weeks, maybe like 2 to 6 weeks, depending on where you're at, within the late spring or early summer. Now, now this is a highly variable depending on the climatic conditions and where you are at as far as location. And as we all know, season to season variability can be tremendous in some areas. Here in Michigan, boy, it seems like the season changes every year, and it's very difficult to rely on hard dates for things to happen. You have to look at the environmental shifts. But this is primarily going to occur it usually occurs, these reproductive swarms are usually occurring at a couple weeks after nectar and pollen were abundant in the landscape. And we usually see that during the first nectar flow at the beginning of the season, which this coincides with. Swarming can also be a behavioral response to overcrowding in the hive. As the population of the colony grows, more space is needed for all the new bees and to increase the storage capacity, store all of that food that your colony is bringing in and using for its growing needs. If you didn't if you're not monitoring the size and growth of your colonies during the season, a swarm really can be due to overcrowding, and that can occur very readily. And you see that in this picture here. What you're seeing is a bunch of bees really ending up on the outside covering of the hive because there's just simply not enough room for the whole colony in the hive. This really creates a vulnerable situation for those on the outside of the hive, and so colonies will swarm to release the pressure of overcrowding from the colony by splitting up the two colonies. Keep in mind, this is still reproduction we're talking about here in this situation with overcrowding swarms. One colony does turn into two, but it occurs more due to specific cues like space limitations, and we'll talk about that in more detail here. All right, so swarming due to overcrowding can happen at any time during the warm season, because this behavior it's not initiated by seasonal shifts like the reproductive swarms are. Rather, it's initiated. It's more correlated with the density of the population in relation to spatial limitations and the reduction of pheromones. So these types of swarms are typically due to a beekeeper who has not managed space in the hive correctly. You've let the colony get too big. They've just overcrowded the space you've given them. And so staying ahead of that and making sure you have space is one of the main strategies that we use to prevent swarming, is supering early in the season. So adding that extra space so that they can grow as the colony begins to grow, and you don't get into a situation where you're totally backed up in the colony. Now, really, when we don't add space, the beekeeper is really in this situation. So by not adding extra space to accommodate for this early on, the beekeeper is really limiting the potential of the colony to grow and is exacerbating all these cues that bees are using to determine when they need to swarm. And so this really brings up kind of an interesting point regarding swarms, and it's an old saying. So there's this old saying when it comes to catching swarms, and I'm gonna have to look and see where this is come from. I've known this quote pretty much my entire career, and I don't actually know where it's come from. It's just a saying that I've heard in the industry. But the saying is, a swarm in May is worth a load of hay, a swarm in June is worth a silver spoon, and a swarm in July isn't worth a fly. Essentially what this passage is relaying is that catching a swarm is it's kind of like starting a package of bees. When you leave the hive, when they leave the hive, they have nothing more than, let's say, the exoskeletons on their backs and the honey in their honey stomachs. We then take that swarm and we dump them into a hive, and they essentially start from scratch, just like a package. They have to find nectar and pollen immediately to begin rearing brood and really storing enough food to make it through the winter. Now, if you catch a swarm early in the season, say May, the bees have plenty of time to store honey and rear brood, and they can overwinter successfully because they have plenty of time to build up. Excuse me. Now, say you catch a swarm early. So, okay, let me back up a minute. So if you catch a swarm early in the season, say in May, they're going to have plenty of time to get ready to overwinter. But as the season progresses, that the chances that the colony can store enough food to make it through the winter, it dramatically decreases. I mean, especially in northern climates, the seasons are so short and so intense that if they're not ready to capitalize on those resources, or if they're too late, there's just no chance to build up enough resources to make it through the winter. So when you think about this in terms of, June, you can probably still make it, so it's worth a silver spoon. But when you get to the July, really trying to establish a swarm into equipment and thinking that they're going to have enough time to put the resources on to make it through winter, you got to think about it in terms of a package. Would you actually install a package in July and expect it to survive the winter? Probably not. And so when you're in these situations with swarms, and I know a lot of you are taking swarm calls, to get free bees, and that's great. But you have to consider that, you're going to catch a swarm in July and you're going to spend all sorts of time trying to get that thing ready for the winter. You're likely in late swarms in the season, you're likely better to just take that queen that was part of that swarm. She's an old queen at that point. Call that queen and combine that with a queen right hive with a young queen going into the winter. So something to think about there. Now, the cues and conditions that are involved in the swarming impulse of a hive, they're complex and involve both cues within the hive and environmental cues. And really the main condition that occurs within the hive that drives swarming is crowding. Whether it's a reproductive swarm in the spring or a crowded swarm any other time of the year, it's really the density and the availability of space to store food and brood that has a huge impact on the cues that initiate swarming. Now, crowded hives are not an indication of a bad thing. I don't want you to think of this as a bad thing. It means you have a lot of food and a lot of bees. There's just too much of all of these good things in the colony. And this competition for space and the reduction in space for brood, it signals swarming because all the needs of the colony, well, they've all been met for reproduction. They've got all of these resources, and now they've got too many of these resources. So now it's time to split those up between two colonies because they're robust enough to do that. And they have the resources necessary to venture out on this very risky behavior of part of the hive, half of that hive going out into the wild and trying to find a new place to call home. That's a very risky time for bees, is this time when they do this. So they only will do this if they have all the right things in place and everything's in a good spot. However, we as beekeepers don't like this because we lose half of our bees. So getting in front of this is important. Again, it's just too much of a good thing is what you've got when you're in these swarming situations. And so we want to make sure that we kind of manage that so that we can capitalize on that and not lose our bees. All right, so the impact of crowding within hive cues, they're really numerous and they really are what drives a lot of the swarm impulses. As population increases, the relative space within the hive decreases, which makes queen pheromone less able to travel throughout the hive. So essentially we're diluting the impact of queen pheromone. In addition, the lack of space for the queen to lay eggs decreases egg production and queen pheromone at the same time. So we're also having a reduction in the actual egg laying that a queen can do. And oftentimes you'll get situations where you may not think you're queen right when you have a colony getting ready to swarm because you're not able to find eggs. That egg production can eventually shut down when there's just no more space to lay eggs. So since space becomes such a big issue in crowded hives, we also have no space for food being brought in either by foragers. So now again, you've got this competition for space. There's no place to put food. There's no place to put eggs. The individuals that are storing food and the queen are jockeying for position this entire time to try and find somewhere to put these things. So what happens is when these foragers start bringing in food and they don't have space above the brood chamber to store it, they start doing what we call backfilling, where they actually start putting nectar and pollen in the brood chamber where it should not be, where eggs and brood should be, not food. And they do that because there's just no other place to put it. What ends up happening also after we have this competition for space is generally when you're in these swarm situations, when you're one of the cues is that you have just a tremendous number of very young bees. So you end up having these situations, and I'm going to show you a picture here in just a few slides where we have this, it's literally you're pulling out frames that are wall-to-wall brood. It is literally an entire frame of brood. Then when you see that, that is an indication that you are going to have a lot of young bees very, very soon. And in these situations, because you have these huge brood hatches with these very large colonies that are competing for space, is that you essentially will get into a situation where you have just tons of young bees hanging out in the colony. Um, and really, they're filling in space in the colony. There's so many of them. And this, I want to draw your attention to this diagram just to kind of highlight this. So this is a diagram from Randy Oliver. And what we can see here, and let me get my cursor here. What we can see here are really what we're looking at in this is we're looking at the compounds, the chemical compounds that are being affected by these crowded conditions that are responsible for swarm impulses in the hive. So here you see, right here in this circle, you see this arrow coming down here to swarming. So what you're seeing here is that really it's a combination. The swarm impulses are initiated by a combination of low levels of queen pheromone caused by either crowded hive or an aging queen, so that competition for space, high levels of brood pheromone caused by a filled brood chamber, and high vitellogenin levels, which so vitellogenin, it's a fatty, it's a complex fatty protein. It's a glycoprotein that really is present. So what I'm trying to get at here, it's without getting deep into vitellogenin, is that it's in high amounts with young bees. So a high vitellogenin amount is an indication of a large number of young bees. So what we're seeing here is that these conditions really, and these cues are really being driven by crowding that we discussed before. So the cues the bees use to determine it's time to swarm, they're directly correlated to population density and storage space available in the hive. So when you get into these situations where you have a colony that's swarming, it's because these things, the population is so high and the storage space is so limited. And those are things that we can prevent as beekeepers through management. All right. Okay, so I'm going to take you through a brief process of what happens with swarming. So what I said earlier is that, really this is a risky venture. So bees, they need to ensure the conditions are right for swarming. They're not going to just venture out just because. This is not just a process that's haphazard. This is a very planned out process. So what this means is that the weather, it's got to be warm enough to allow for a swarm to survive for a few days. So they may be, out on the side of a building, on a tree branch, something like that for a couple days as they try to find a new permanent home. And so nighttime lows are generally going to be non-freezing temperatures. So you're going to have warm days, above freezing nighttime lows. This is generally going to happen when there's lots of pollen and nectar available as well, because there has to be resources in the landscape to support you once you leave that big colony with all those resources. And generally, you're going to see with earlier swarms, you're going to see increases in day length. Now, with reproductive swarms. Now, crowded swarms can happen at any time. So day length has nothing to do with that. That is more to space limitations than anything else. But with reproductive swarms, increasing day length is one of those cues. Okay, so now during the lead up to the swarm, nectar is coming in and they don't have enough space to put it in the hive because the hive is thick with brood. And what they want to do is they want to put it above the brood chamber. They want to store it above the brood chamber like they always do. But if there's not drawn out comb available above them, they're going to just start storing it anywhere. And this is something that happens a lot of times. I see this happen a lot of times with folks who purchase nukes. That some folks that are selling nukes sell these nukes that literally are ready to swarm when you purchase them. They look like they're super robust. There's tons of bees in them, and then they swarm on you when you install them into new equipment because you don't have any drawn frames for them to do anything with. Undrawn frames, that is not additional space. That is just undrawn frames. Drawn comb is additional space. So in these types of situations where they don't have enough storage space, they want to put that above the brood chamber where it should be. There's just not the space to do it. And so what ends up happening is they start to store it in the comb that would be utilized for rearing brood. So that's where this process really gets going, is you get this situation where food's being stored where brood should be being stored. This lack of space that I'm talking about, and I said it earlier, for nectar and pollen, it's a process that is, well, the process is backfilling. So the lack of space initiates this process where they just start storing honey and pollen wherever they can. And you can see in these pictures that what we're looking at here, and let me grab my cursor here, is like on this picture on the right, I think it's better than the one on the left. You really got to look closely. But on the picture on the right, you can see this is where brood, this is in the brood chamber. You see this shiny water-like substance in here? That is uncured nectar, or that is nectar that's uncured. You know, it's on its way to becoming honey, but it's going through a curing process where it's drying down. But this is essentially nectar that's in the brood chamber. And now those cells that are full of nectar, that queen cannot lay in those cells. There's no place to do that. Now, if there was somewhere else to move this stuff, they can move it. They will move it out of the brood chamber into drawn wax. But if you don't have drawn foundation, if you don't have drawn wax on that foundation, raw foundation is not a place you can store honey. So this is a situation that you kind of have to get in front of to make sure you don't get into these the situation where you have space limitations. When you're doing a hive inspection, and if you see this, even if you don't see any other symptoms of that may indicate that you may be getting close to swarming, if you see backfilling, that is a key indication that you're short on space. And if you see it, you need to rectify that quickly. And there's many ways to do that, but you need to rectify that pretty quickly. So that's a key indicator. All right, so since the bees are backfilling with nectar, this reduces the available space for the queen to lay, which in turn reduces egg production. And really what this does is this has this cascading effect on the queen because it reduces the amount of queen pheromone she's releasing and causes her abdomen to slim down. And this is in preparation for her to be able to fly once they leave as a swarm. So there, and I think I said this earlier, you know, there are situations where you may have a colony that's queen right that is so backfilled and so just on its way to swarming that you may not see eggs. And you may think you're in a queenless situation when in actuality, there's a queen there. It's just there is nowhere to lay. And then you are well on your way to a swarm at that point. So that's something to really keep in mind is that, you know, we're talking about space limitations. Again, the way I like to reference is it's a competition for space. It is a competition for space. You've got to give them enough space to store resources so that you don't have the queen and workers competing for storage space. All right, so this decreasing in egg laying also corresponds with a very large hatch of young bees. Typically, you have these frames that are just packed full of young bees. And we should all know that when bees hatch, one of the first jobs that they have is as a nurse bee caring for young brood. So in the lead up to a swarm, since there's little brood activity, because you've had this huge hatch out and now they're backfilling that brood chamber with nectar and pollen. So since there's little brood due to this decreased laying activity and backfilling, these nurse bees are essentially displaced from their normal feeding patterns, and they just begin to really hang out on the lower portions of frames, and even sometimes on the hive entrances. So when you pull out big frames that are just, you know, out of a huge colony, and you have this thick band of bees at the bottom of them that's just hanging out, that is an indication that you have a lot of young bees that don't have a lot to do. And they can end up spilling out onto your, you know, the front of your hive. Oftentimes you'll see folks that show you these pictures that they're, you know, front of the hive is just totally covered in bees. You know, that can sometimes be due to heat, but most of the time it's due to overcrowding. And so that's really what we're looking at. So we've displaced these workers from their job as nurse bees, and now they're just hanging out. And these bees, what they're essentially doing is they're essentially waiting for the swarm to occur. They're sometimes, I've heard them referred to in the past as active swarm bees, because these are the bees that are going to leave the colony with the old queen once swarming actually commences. So, very interesting process that they're going through. But some of the things to underscore is that these are all things that we can see happening in our inspection, that we can see actually happening. We just have to know what the cues are that we're looking for to be able to determine that. All right, so once all of these processes occur, the colony is ready to swarm. But what I want you to understand is that just like we talked about earlier regarding conditions to initiate swarm impulse, the conditions need to be right to make survival of the swarm and the remaining colony as likely as possible when the swarm occurs. So bees will wait for a break in weather to actually swarm. Typically, they're going to swarm in warm weather with good flying conditions, above freezing nights, and they tend to swarm in the middle of the day. So that's kind of the process of that is when it occurs. When the swarm leaves, the workers essentially that are going to be leaving on with that swarm gorge themselves on honey, and they're going to leave all at once in a huge group in which the old queen is really just swept up in the swarm. They're going to go to somewhere nearby, somewhere that's been scouted, and they're going to hang out there for a little bit. Typically, this is something that's not too far from where the swarm initiated. Most of the time, you'll see folks that'll post things that, if they're had a hive that swarmed, that it swarmed up into 30 feet up into a tree, next to the colony. That is a temporary spot. That is that first initial spot, and even maybe a subsequent spot, those tend to be temporary. What's happening during that process, the colony is swarmed, but they have scouts out that are looking for a permanent home. And once they do identify an appropriate permanent home for that swarm, those scouts will come back, and they're basically going to communicate the location of that swarm location with a dance similar to the waggle dance, which they use for locating resource or for communicating the location of resources. In these spots, like I said, they tend to be temporary. The first spot, they may hang out there for an hour, they may hang out there for a day, but generally they're going to move pretty quickly. And so when you have folks that say, "Oh, I have a swarm available," or "I found a swarm," or something like that, those things are not, they're gonna be gone pretty quickly. So you got to jump on those opportunities if you're in the position where you want to be catching swarms for those free bees. Okay, so one of the big misconceptions of swarming is that swarms will hurt you. Most people are not comfortable with tens of thousands of bees flying around in a cloud. A lot of people are horrified by it, especially the general public who does not understand honeybees. But in actuality, swarms are really the safest time to handle bees that you could be part of. Because the workers have gorged themselves on honey before they left the colony, and because they're so focused on the queen and finding a new home, they're very unlikely to sting during this period. And in fact, I've had many times where, I more or less to show how safe swarms are. When I worked at Cal Poly with the apiculture instructor there, we would go catch swarms on university property all the time. And one of the things that we would do with the apiculture class is that those of us that were working in a kind of a TA position would go with the class, take them to a swarm call on campus. And one of the things I used to like to do is I would poke my hand into the middle of the swarm and talk about how warm it was, and talk about how it felt, and how the fact that this was the safest time that you could possibly be around bees. And it really changes people's perceptions of swarms. They're very safe to be around. You're very unlikely to get stung by a swarm. And you can see this picture here, me with this. I always wear a veil just because I want to make sure. I don't like getting stung in the face. It's not a fun thing for me. I don't mind getting stung anywhere else, but the face is a sensitive spot. And I don't like having to explain to my colleagues why I look like I got beat up in a bar fight after getting stung in the face by bees. So this is really a safe time to be around them. You can see that I'm just picking up this swarm. It was on a branch here at the farm, and I'm just going to relocate that. And essentially, all you do is I'm in this situation. I just took that branch of bees. I put some equipment together and had an empty, basically a full drawn box on the bottom. Added a second box that had no frames in it, and shook this into that box, and then added frames to that second box. Very easy process. I've done this with 5-gallon paint cans, where you just throw them in a paint can that's got some holes in it, and transfer them. I have a bee vac that I use to suck these up sometimes if we're doing a call. I don't really do much swarm removal anymore. I did earlier in my career to kind of help get bees and things like that, but we don't do a lot of it anymore. But we have a bee vac that we would use to do to go suck bees out of walls and things like that. Totally safe for the bees, and you just transfer them into a colony. So very safe time to be around. All right. So we've talked about all the swarms. We've talked about what's causing it. And now we want to talk about what do we do to prevent them. So it's our jobs as beekeepers to ensure we manage our colonies to avoid these swarming triggers. And we've also discussed that the primary driver of swarming is crowded hive conditions, which impact swarm queues within the hive. So it's critical, really critical, that you guys understand the three main ways to tell bees are crowded to prevent possible swarms from occurring. The first way to tell is to recognize that you have a colony with lots of young bees or wall-to-wall brood. Young bees are pretty easy to identify. I'll be very honest with you. And you can see in this picture that, of this bee emerging, that this bee actually looks very different than most of our older bees when you look at them very closely. They're very furry. The fur tends to be, kind of all over their bodies as far as the thorax and the head is concerned. With older bees, they lose their hair. So the thorax actually starts to bald a little bit as they age. So you can tell the age of a worker bee just by the hair on it. Another key indicator is the margins of their wings. So the edges of the wings get tattered as bees get older because they're out foraging as they age. That has an impact on the wings of the bees. Young bees will always have very clean margins that are not tattered. And so that's another way that you can typically tell that you have young bees. So you want to be able to learn how to recognize that you have a chamber full of young bees in there. The other thing, being able to tell what a young bee looks like is one thing, but really the telltale sign that you are on the brink of having just a ton of young bees is these full wall-to-wall brood frames. And if you've been beekeeping for any sort of time, you know what this looks like. It occurs really, really readily. Usually you'll come out in a hive inspection and you'll be like, wow, there is just all sorts of brood here. Now, it's not just that you have a bunch of bees, in these cells. It means that within the next, couple weeks, you're going to have oodles of young bees in this colony. All of this is going to hatch out. And most of the time when you see this, this is not one frame that looks like this. Usually this is a box or two boxes that looks like this. And you want to be able to understand that this is a clear indication that I am going to have a ton of young bees very, very, very quickly to deal with. All right, so another thing that we discussed was backfilling, which is also a key indicator that swarming is imminent. It's important that when you're evaluating your hives, when you're going through your regular inspections, that you look for this. It's very easy to see, but oftentimes it can be mistaken for other things that people for beekeepers that maybe are not as well versed in what these things look like. But oftentimes I think we just don't get close enough to the bees. I've had many people over the years that will look at a picture on the like you see on the left and say just from that distance, from an arm's length, oh, that's spotty brood, I've got a disease. That is absolutely not spotty brood, not the spotty brood that we talk about when we talk about disease and what spotty brood looks like then. This is spotty brood that's there because there's no room to put anything else. So, excuse me. So simply by bringing that frame a little bit closer, like we have in the second picture, you can clearly see that that is backfilling. That is not spotty brood. There's no place for the queen to lay an egg. How can it be spotty if there's no place for her to lay an egg? So that's something that oftentimes comes up. People freak out when they see this and say, oh, I've got spotty brood, I've got a disease. No, you're on your way to swarming, which is a totally different thing than trying to treat disease. So be aware that this is a clear symptom that you are on your way to swarming. All right, so lastly, when we're doing inspections, one of the things that I always kind of like to do during these situations if I get into a situation where I see that I've got backfilling or I've got this wall-to-wall brood, one of the other things that you can do is also look for swarm cells. Now, swarm cells can occur anywhere, but a lot of times you see them on the bottoms of the frames. And what I generally will do, like in this picture, is I tip back the box and just look at the bottoms of the frames to see if I have any queen cells that are being developed. This doesn't require taking any frames out. This literally just requires opening a box and peeking at the bottom of the frames to see if there are any queen cells. Now, we've talked about this in previous lectures, and so I would refer you back to the biology lectures, but One thing to keep in mind is that there is a difference between a queen cell and a queen cup. A queen cup is something that is totally normal to be occurring in a hive. They oftentimes will make queen cups all over the hive, but they are not occupied by anything. So a queen cup is just an empty queen cell. A queen cup is a queen cell soon to be if an egg is laid in it. If an egg is laid in a queen cup, it becomes a queen cell at that point, and now there is actually a queen being reared in it. Just because you see queen cups does not mean you are on your way to a swarm. Hives that have no swarm pressure are not on their way to swarming. Oftentimes will have queen cups all over the place. It does not mean that you're swarming. There has to be an egg in there or a larva in there in order to really illustrate that this is an active situation where we are going to be swarming imminently. All right, so I'm going to share with you a couple techniques to basically prevent swarm triggers. The first one is to prevent crowding. It's the easiest one by far. You start early in the season with trying to mitigate crowding. The first way that you can, and you can generally do this two ways to prevent crowding. One, you can put supers on early. So one thing to keep in mind is over the course of the winter, that colony is, as a cluster, is moving up in the hive, feeding on honey stores that are above the cluster. So it moves up. So by the end of the winter, you have colonies, a cluster that has gone through, say, 2 or 3 boxes of honey. That cluster is now at the top of the hive body stack of a hive. And now you have space below, but you have no space above. So if you have a situation where you come out of winter and you have this colony that's building in the spring and you don't put space above it, it can swarm just in that box because it's not going to go back down into the box. So this is not a completely fluid situation when we get to reversals, but when it comes to something that anybody can do in this situation coming out of winter, one of the biggest strategies that you can use is put supers on early. Put them on early. As soon as you start to see those colonies building up, throw supers on them. Throw a couple supers on an overwinter colony as they're coming out of winter. That way that they have space to work on. If they're, ideally you want drawn comb, but if you don't have that, still add space. But ideally you would want drawn comb in this situation. Now, some of you may be saying to yourself, well, I don't have drawn comb. How can I do that? Well, that's where spring reversals can come in. So you can put supers on. That's one way to add space. Make sure they're drawn comb. Or you can do what we call a spring reversal. Now, this is a very simplified diagram of a spring reversal. Typically, spring reversals involve this. You have the colony that's up at the top of the boxes. It may, in most situations, it's not, the cluster is not in one box. Typically, it'll span a couple boxes. The thing that you want to keep in mind is when you're doing a spring reversal, you are never, never going to reverse anything in the boxes that are occupied by bees. What you're doing is you're taking the boxes that are down below that were originally the brood chamber going into winter, and those boxes that are empty and unoccupied, you take those boxes out and then you put them on top. Those boxes have drawn comb in them. The bees will readily start storing in them. And so it's like adding supers. This does not always work. In some situations, and I have several Saskatraz colonies up here that I never do spring reversals with because they always occupy the entire stack of hive bodies. And so spring reversals are not necessary. But other colonies that I have that have gone all the way to the top of, say, a hot 5 hive body stack, and they're not occupying those bottom boxes, I can take those bottom boxes and put them on top and bring that brood chamber back down to where it should be. So that's what we mean by a spring reversal. I don't want to be, this diagram, and I need to make my own diagram around this, but this diagram kind of illustrates that it's as simple as taking the top box and putting it on the bottom and the bottom box and putting it on the top. That's not what it is. What it is we're taking the boxes that are unoccupied on the bottom and putting them on top of the boxes that are occupied, which may include several boxes of bees. So just keep that in mind. All right, so another way to prevent swarming, so we had this is the crowding portion of that. This is the portion to prevent backfilling. So both of these will work to prevent backfilling, the stuff I just talked about, spring reversals and adding supers. will prevent backfilling. Yeah, see it here. It's on my bullet here. So preventing backfilling. You're going to add supers with drawn comb. I know you've heard me talk about this, and I think we talked about it in one of the MSU apiculture webinars that you all had sent out earlier this year, that were not part of the Heroes to Hives curriculum, but were added as bonus lectures. But one of the things we talked about was the value of drawn comb. It is worth its weight in gold to a beekeeper, because it is essentially, you're alleviating all the work that has to go in to draw wax, which is a very, very, very resource intensive process. It takes a lot of nectar to draw wax. So if you can mitigate the need to invest all of that energy into producing wax, you can start storing honey very, very quickly. That's where the drawn comb comes in. Another technique that is talked about a lot, I get a lot of questions about this. This is not something that I practice at all. Typically just adding supers at the right time, you're not gonna be dealing with backfilling. But there are a lot of folks that ask me about checkerboarding, so I've added it in here. Checkerboarding, number one, checkerboarding is not something that happens in the brood chamber. I want to be real clear about that, because that's one of the main questions that I get is, how do I checkerboard my brood chamber? You're not going to checkerboard in a brood chamber. You're going to checkerboard your honey supers. And so what you're doing is you're checkerboarding with drawn comb. You're not checkerboarding with undrawn foundation. Again, undrawn foundation is nothing. It is not a place to store. It is a place to work, to draw comb, but it is not a place that can be utilized to store anything when it's put in. And in these situations where you're trying to prevent backfilling, you need places for them to store now, not places for them to store 2 or 3 weeks from now. And so it's very important that you understand that if you are doing checkerboarding, number one, you are not checkerboarding the brood chamber. Number two, you're checkerboarding supers, and this is how you do it. So I have on this diagram, you see you have the first super, so that's the immediate super above the brood chamber, and then the second super. And essentially what you're doing is, if you had a band of honey, so if that first super was entirely full of honey and was literally bound by honey, what you're going to be doing is you're going to be adding another box to the top of that and then splitting those frames up between in an alternating fashion. And that is one technique that you can use. However, the only reason it's on here is because I get so many questions about it. The main thing I want to drill into your mind is that get supers on early and make sure they're with drawn comb, and this won't be an issue. But backfilling, or I'm sorry, checkerboarding is a technique that can be utilized in this situation. All right. Lastly, we can prevent crowding as a trigger by moving those huge brood frames that are wall-to-wall brood to weaker colonies. To one, release the pressure on the colony that we're taking, that has it, and two, to give a little boost to those smaller colonies that we have. Oftentimes during this time of the season, invariably, if you have multiple hives, and I always talk about you should have 2 to 3 hives to get started, no more, no less. But when you're getting started, and you are in a situation where you need to be relieving crowding pressure, this is a great opportunity to support those weaker hives in your colony by adding a big boost of brood there. So you can actually, when you see these wall-to-wall brood frames, generally the first thing I think of when I'm doing inspections, if I start to see this, is what colonies do I have that have been kind of struggling along, maybe just haven't had enough boost in workforce population? What colonies can I give these big brood frames to support them? And in turn, I take out that drawn frame that's in that other colony and put it in here to add space. So this is one way that we can do that. This is also a way where you can create nukes that you can sell. Is you can take these brood frames, add a queen cell in there, or a mated queen, and boom, you've got a fully functioning colony at that point. Because the workforce that's going to hatch from this is going to be huge relatively quickly. So that's another thing you can do. You can also use these for starter colonies for queen rearing. So there's multiple uses that you can have for these large brood frames. You don't just have to say, oh my gosh, I have to hold on and just hope that they don't get too full. No, you can actively manage this process to ensure that your colonies are not swarming and that you're capitalizing on all these resources. This big brood frame, that's a hell of a resource to have in your apiary to support your colonies. If you have colonies that are a little weak, boy, what a good infusion of workforce. If you want to create a nuke to sell to somebody, well, dang, you've now mitigated some cost for your beekeeping operation by selling a nuke. Or if you want to get started in queen rearing, there you go again. This is a way to get started on that and be able to support those starter colonies for queen rearing. All right, so laying workers. So this may seem like an odd place to kind of break and get into laying workers, but what I want to say is that, okay, so let me back up a second. Laying workers, it's it's something we always try to avoid, but it is a symptom of a very serious and potentially lethal condition to the colony. So typically this condition arises in new colonies with virgin queens, like, and so this is where it's correlated to swarming. So typically this condition, it's going to be with virgin queens. And what happens is, say for example, the virgin queen leaves the colony behind after a swarm to go mate. So the swarm left, and now you've got a virgin that needs to go on a mating flight and get mated. That mating flight is the riskiest time of her life. And I've heard a lot of stats over the years around, you know, how many queens that leave, how many virgins that leave the colony never come back. One of the ones that's always kind of rung true for me, at least from my personal experience, is about 80% of the time the queen will come back. About 20% of the time something happens to her, whether it's being picked off by a predator like a bird or getting caught in some sort of, you know, climactic condition, but predation tends to be the big one. And if she's eaten out in the landscape, this may get you into a situation, especially after a swarm, where you could get into some trouble. The other time that laying worker situations tend to occur is when there's beekeeper error. And this is typically due to poor hive handling. I've got a lot of folks that will do hive inspections and have a queen right colony and say, oh yeah, I was good to go. And then I came back 3 weeks and I don't have a queen and I have a laying worker situation. Sometimes those situations are due to us. You put a colony back together and you roll a queen, boom, that queen's done. Put a colony back together and you pinch a queen, you know, between the sidewall of the hive body and the frame, that queen is done. And at that point, you now have lost a queen due to your own personal poor hive handling skills. Again, most of this is totally, we can totally mitigate with proper management. Hive handling is a very important thing to keep in mind and a very important thing to practice. The gentleness of which you remove and put back frames is very important. And you can very easily kill a queen not with poor hive handling skills. Now, really, with all of these situations, there is some ability to recover from these situations. It's not totally hopeless, okay? Under certain conditions. And these conditions are very specific. In order for a colony to be able to recover from a queen being lost, whether it's through your error or her dying on a mating flight, the only way a colony can recover, meaning that it raises a new queen without your assistance at this point. I mean, if this is a situation where you noticed you killed a queen, you can add a queen immediately and totally avoid this. But if you did not recognize this, and you've gotten into a situation now where your colony, you had a queen that failed due to being killed on her mating flight, or something you did, and it was not recognized early on, the only way they can recover from this as a colony is if there are eggs present or first-day-old larvae. So you only have a 4-day window of these immature stages of honeybees in order for them to be able to raise a queen from it. After day 4, they cannot raise a queen from that larva. They cannot. It's not possible. So you have to have the right life stages in the colony in order to be able to recover from this. If you don't have eggs or first-day-old larvae, things go sideways really, really fast. And this is something that I want you to take very, very seriously, because if you do nothing about this, this is what's going to happen. what we call a colony that has a laying worker situation. We call this colony a hopelessly queenless colony, meaning there were no eggs or young larvae to produce a queen from, so they have no ability to produce a queen. The colony becomes very stressed, and you will notice that the colonies that have gone queenless, there's a term that we use sometimes called a queenless roar, where you open up a colony after beekeeping enough years, you open up a colony and you see a queenless colony without even pulling out a frame. Generally, you can tell a colony is queenless based on how they are reacting. They tend to have this queenless roar. They tend to be much more agitated. They move much more quickly. They become more aggressive. They're in a very, very stressful situation. There's no queen pheromone in there. And so what happens in this situation, because you have no queen and no ability to raise a queen, so there's no queen pheromone in here, brood pheromone falls off of a cliff, because generally the brood is very limited in these situations. Most of what you're seeing here leads to a situation where worker bees, and it's not just one, but many worker bees, their ovaries will actually develop. So all of these cues that we've been talking about, these queen pheromone cues, that pheromone keeps those ovaries of workers in check. It keeps them so that they're undeveloped. But when there is no queen pheromone present in the colony, those ovaries develop and the workers will start laying eggs. Now, let's talk about that a little bit. Well, if we refer back to our biology lecture, you'll know that yes, workers are females, and you should all know that. The other thing that you may not know is that they can lay eggs, but they lay unfertilized eggs because they've never been mated like a queen. And so unfertilized eggs in the bee world are male bees. They're drone bees. And so what you'll end up with in a queenless situation is that you will have laying workers that will lay all over the place. They're very messy layers, but they will only produce drones. Now, the big thing to keep in mind here is that the way you recognize this, so we've talked about losing a queen. You may not recognize that, and you may get to this situation where you're in a hopelessly queenless situation, a laying worker situation. Excuse me. So what I want you to do, there is a very easy way to determine if you have a laying worker situation. And this picture here illustrates it perfectly. Again, I have tried to underscore how important it is for you to be able to recognize what's in these cells. You need to be able to see eggs. I know some of us have trouble with that, especially those of us that wear glasses. But you need to be able to figure out how you can best see them, whether that's with a magnifying glass and a flashlight or whatever. You need to be able to see these eggs. It is one of the major diagnostic tools that we use when we inspect colonies, and it's no different here. The way you tell that you have a laying worker colony is that you look inside of these cells and you see multiple eggs in every single cell. So let's look here. I'm going to draw my cursor over it. This cell right here has 3 eggs in it. This cell has 3 eggs in it. This cell has probably, 1, 2, 3, 4, 5, 6 eggs in it. This next cell has 3 eggs in it. This cell has just a whole ton of eggs in it. Oops. All right, there we're back to the picture. Sorry about that. So I got so excited because look at all these darn eggs that are in here. All right, so the way you tell you have a laying worker situation is you look in the cells and you see multiple eggs. There are just tons of eggs in here. A queen-right colony will never look like this. Never. The queen is so good at what she does. She will always lay a single egg positioned at the very bottom of the cell perfectly. Every single time. She's a dynamo when it comes to being exact in the process that she's for. Laying workers, they just make a mess of things, and there's just eggs everywhere. They're on the sidewalls. You'll oftentimes see them on pollen. They will just be all over the place. And why? Because they're just messy layers. They're not exact, and their abdomens are much shorter than the queen. So many times they can't even reach the bottom of the cell. So that's why you get these messy situations. This is the diagnostic characteristic of a laying worker colony. If you see this 100% of the time, you have a laying worker colony. That's it. There's nothing else that looks like this. So you don't even have to think about anything else. If you see multiple eggs in a cell, it is a laying worker colony, plain and simple. What's the result of all of this? Well, because we have a lack of workers being born, the population of the colony really sees a dramatic reduction. Drones don't do anything. And in addition, the drones that are being raised by a laying worker colony, they're much smaller than typical drones because workers don't recognize the sex of the larva in laying worker situations, mainly because drones are laid typically in worker cells. So they're smaller cells to begin with. Drone cells are larger cells than worker cells. And what this results in is dwarfed drones that are malnourished because they're fed like workers. So instead of having big, healthy drones, they kind of fumble around. And I know you've all seen them if you've got bee colonies, and you've seen them in lots of pictures. You end up with these small drones that are really worthless to the colony. Drones do not contribute to the allocation of resources of a colony. They are there for one purpose and one purpose only, and that is mating. So a colony full of drones is worthless. We call that a hopelessly queenless situation for a reason. It is hopeless. All right, what I want to underscore here within this is that this has a dramatic impact on the colony when you get to this situation. Like I said, it goes sideways very quickly. I mean, we're talking a matter of weeks here, where you could go from a queen right colony to a laying worker colony very, very quickly under the right conditions. What happens in this situation? Well, this is what happens. All sorts of reductions in activities that are normal for a healthy bee colony. Comb production reduced by 73%. Flight activity reduced by 77%. The number of bees coming in with pollen loads reduced by 73%. Pollen load by weight being used in the colony drops by 50%, and nectar allocation coming into the colony reduced by 81% in a hopelessly queenless colony. That is a recipe for disaster. And this is what happens because of it. So in this hopelessly queenless colony, you essentially have a dead hive if you do nothing with it. You, plain and simple. The bees will then end up just absconding, and the hive will be empty. This is hopelessly queenless. Now, the reason we say it's hopelessly queenless, and that's a very intentional term, is because there is no way to recover from this and make this a queen right colony. You can buy queens all day long. Mated, you could buy cells, you could buy virgin queens. It does not matter. They will not accept that queen, period. There is no way you could throw money at it all day long. There is no way you are going to recover from this. No way possible. It's just not possible. When you get in these situations, that term, again, it's very, very intentional. Hopelessly queenless means exactly what it says. There is no way to get this queen right, period. The only option you have in a hopelessly queenless colony is to combine it with a queen right colony. Now, you could split it at a later date and raise a queen when you've got eggs in that colony again, but at this point in time, you have no other options. You need to just take a piece of newspaper and combine that with a queen right colony using the newspaper combine method. In this situation, you will mitigate your losses. You will be able to recover those bees that were in that colony. And again, they're going to get queen right in that colony eventually. And if you really, really wanted that second colony, you can split it at a later time by taking a frame of eggs and all of that good and all of the good stuff that you need to make a fully queen right colony. You know, eggs, cat brood, food, some space to make a split, and you can do that. But it has to get queen right first being combined with a queen right colony. They've got to get that laying worker impulse out. And the only way to do that is to combine it with a strong queen-right colony. So that's how you do this, is you get it, you combine it with a queen-right colony. It's the only solution, which is why I only have one slide that illustrates this solution. There are no other techniques. That is the technique. Combine it with a queen-right colony. The thing that I'm going to leave you with is that beekeeping is dynamic. And I've said this in other lectures, and I say it all the time when I talk to beekeeping clubs. We all get hung up on this idea that I have 10 hives or I have 5 hives. It's like a badge of honor a lot of people wear. Oh, I have 30 hives. Oh, I have 50 hives. I keep 10 hives. Beekeeping is a dynamic process. It doesn't matter how many hives you have. It matters how healthy your colonies are. And one of the things that you need to keep in mind is that the number of colonies you have is going to fluctuate over the year. When people ask me how many colonies I have, I tend to say I have somewhere between 40 and 50 colonies because it's always fluctuating. Sometimes I'm going to have increases because of splits. Sometimes I'm going to have decreases because of combines. Sometimes I'm going to go into the fall and I'm going to combine a bunch of weak colonies so that I ensure I have strong colonies going in the winter. Those numbers fluctuate. Don't get hung up on I have 2 colonies and that's what I have. No, you need to make sure you're doing what's right by your animal and ensuring that they have the best chance to survive. Whether that means you combine 2 colonies into one or you take 1 colony and turn it into 5, it doesn't really matter. You're doing what's right by the organism. And in this situation, the only way to do this is to combine. Only way to rectify a laying worker situation is to combine. Okay, so in both of these situations that we talked about today, swarms and laying workers, it really should be obvious to you that you as the beekeeper are in control of all of this. There's ways to prevent swarming by managing hive space. There's ways to use swarming to our advantages, like creating nukes. There's ways to support bees in emergency situations that can result from losing a queen, like combining a hopelessly queenless colony. And really, ultimately, all of this is up to you, and your knowledge base is what you need to use to address these situations. You all as veterans, one of the biggest reasons I think that we as veterans are some of the most well-positioned people to work in agriculture, beekeeping and otherwise, is because we have been taught to make critical decisions on our feet when the costs are much, much higher than just beekeeping or agriculture. Many of you have been in situations where you had to make split-second decisions that were life and death. This is your opportunity for the same type of interaction by critically thinking your way through these situations based on the knowledge you have. So every time you go into a bee colony, I want you to come back to the idea that, we call it beginner's mind, right? Come to an apiary with the beginner's mind, where you're looking at a colony and you don't have any preconceived notions. Every time you go through that colony, you're going through a systematic process of evaluating what is going on. And every colony can be different. And you really are going to have to be quick on your feet in order to make these decisions correctly. You're going to rely on your ability to have that beginner's mind and be present and absorb what you're seeing there, but also the application of the knowledge that you've had, taking that critical thinking practice that you developed in the military and applying it to your agricultural endeavors. I really hope that this was helpful for many of you and answered a lot of questions about swarming and laying workers. And I'll look forward to seeing you at the next lecture.